These are some quick notes on simplifying and combining radicals, and this might be a topic that you are familiar with, but the first thing that we need to know when it comes to simplifying radicals is what are the perfect squares. So on the back of this page, you've got your perfect squares all the way up through 15 squared. And so these are numbers that you really need to start memorizing throughout the rest of your math career. And I know it seems overwhelming at first, but the more that you are exposed to them and work with them, the easier it will get. So we are going to be referring to these perfect squares. All right, simplifying radicals. What do we do when we have a number inside of a square root that's not a perfect square? We can actually rewrite them in a simplified form, and we do that by finding factors of that number that are perfect squares. Now, again, this is also going to take some practice, and you might not always recognize right away what factors of numbers are, so you can do a little bit of guess and check. So starting with 98, I want to find factors of 98 that are perfect squares. So you might not know that right away, so what I would suggest doing is in your calculator, divide 98 by some perfect square. So let's try 4. No. Let's try 9. No. Let's try 16. And so on, until you find a perfect square. And this one is actually going to be 49. So 49 times 2 is 98, so let's rewrite our radical that way. 49 times 2. 49 being the perfect square. So I can take the square root of 49 out of my radical. The square root of 49 is 7, and the 2 stays inside my radical. And you know that your radical is in simplest form when your number inside is either prime or has no factors that are perfect squares. So 2 is a prime number, so we have completely simplified 7 square root of 2. Okay, let's practice this again. 45. Hopefully you recognize that 9 is a factor of 45, 9 being a perfect square. So that's 9 times 5. I can take out the square root of 9, which is 3, if my camera will focus. And 5 is left inside of my radical. 5 is prime, so this has been simplified completely. Square root of 24. We know that 4 is a factor. I can take out the square root of 4, which is 2. And that leaves 6 inside my radical. 6 is not prime, but my factors of 6, 1, 6, 2, and 3, none of those are perfect squares, so this has been simplified completely. Okay, now we're going to be looking at a slightly different situation, which is when I have a number being multiplied by my radical, and that's going to come into play when we're taking the number out. So first, let's focus on the number inside. 128. Again, you could go down your perfect squares list to find what factors of 128 are perfect squares. So for right now, I'm going to leave that 3 on the outside, and the factor of 128 that's a perfect square is 64. So 64 times 2. So again, this 3 is going to stay out here. The square root of 64 is 8, and I leave 2 inside my radical. I know that this has been completely simplified because 2 is a prime number. Now, what is the relationship going to be with this 3 that was on the outside already and then the 8 I brought out? Those are going to be multiplied together outside your radical. So 3 times 8 is 24, and then your radical is still 2. So 24 square root of 2 is the final answer. Okay, let's practice this again. 5 square root of 72. I need to find factors of 72 that are perfect squares. That's going to be 36 times 2. So again, I can bring out the square root of 36, which is 6. 2 stays inside my radical, and these two constants outside are going to be multiplied. So that gives me 30 square root of 2. So that is simplifying our radicals when we don't have perfect squares. Okay. Another thing we can do with radicals is add and subtract them. Now, the thing about adding and subtracting radicals is they have to be like terms. This means that the radical has to match. You cannot add the square root of 2 plus the square root of 3. The number inside the radical is not the same. So in order to be able to add or subtract radicals, you need matching numbers inside, and the way that you combine these is you add or subtract their coefficients and you leave the radical the same. So looking here on this first one, 5 square root of 2 plus the square root of 2. We assume that that coefficient is 1. My radicals do match, so these are like terms. So let's add our coefficients. 5 plus 1 is 6, and my radical stays the same. So that would be 6 square root of 2. Okay. Next one, 2 square root of 3 minus 4 square root of 3. Again, I have matching radicals, so these are like terms, and I'm going to subtract their coefficients. 2 minus 4 is negative 2, and my radical stays the same, so 2 square root of 3. Now on this next one, I don't have matching radicals, but we might be able to get a matching radical if we simplify this one on the left. So 3 square root of 24. I can simplify the square root of 24 because one of its factors is 4, which is a perfect square. So if I bring out square root of 4, that's going to be 2, multiply it by the 3, that gives me 6 square root of 6 minus 9 square root of 6. And now I do have like terms. They both have the square root of 6. So I can subtract their coefficients. 6 minus 9 gives us negative 3, and our radical stays the same. All right, now this last one. 4 square root of 5 plus 3 square root of 10. My radicals do not match, and the square root of 10 has no factors that are perfect squares. 1, 10, 2, and 5, none of those are perfect squares. So this cannot be simplified any further, so I cannot combine these terms. So you have to leave it as the sum of those two radicals. Because what's inside the square root does not match, you cannot combine them. Okay? All right, and then the last skill we're going to look at is multiplying radicals. Now, to multiply radicals, they don't have to match exactly. Adding and subtracting they do, but multiplying they do not. So for multiplying radicals, what you do is you multiply what's outside the radicals together, so your coefficients in front, and then you multiply what's inside the radicals together and simplify if possible. So let's look at this first example. 5 square root of 7 times 7 square root of 7. Multiply your coefficients. 5 times 7 is 35. And then you're going to multiply what's inside your radicals together. So 7 times 7 is 49. And then again, we simplify if possible. What is the square root of 49? Well, that's 7. So that's going to be 35 times 7, which is 245. I've got another example here, 2 square root of 5 times 6. Now this is the same thing as like 6 times the square root of 1. So I'm going to multiply my coefficients. 2 times 6 is 12. And then I'm going to multiply what's inside my radicals together. 5 times 1 just leaves me with the square root of 5. So 12 on the square root of 5. So let's do a couple of other quick practice problems just for extra reinforcement. Go ahead and give a couple of these an attempt on your own. You've got those perfect squares at the top already, so go ahead and see what you can do and pause the video and then resume when you're ready to check your work. Okay, let's look at these together. 72. 72. What factors of 72 are perfect squares? That would be 36 times 2. So you can bring out the square root of 36, which is 6. Wonderful. Square root of 162. This is the square root of 81 times 2. Square root of 81, of course, is 9, so that leaves us with 9 square root of 2. Square root of 28, that is going to give us 4 times 7, 4 being a perfect square, so that is 2 square root of 7. Square root of 48, that is 16 times 3, so I can bring out the square root of 16, which is 4, and 3 is inside my radical. All right, number 5, the square root of 6 squared. When you take the square root of something that's being squared, it just cancels that exponent. So that is going to be 6. No simplifying really needing to be done there. Okay. Square root of 242. 242. That's a bigger number. So if we start punching in numbers into our calculator looking for a perfect square, we are going to find that this is 121 times 2. Square root of 121 is 11. Square root of 2 stays inside your radical. Now on number 7, we're multiplying radicals. So remember, multiply what's outside together, multiply what's inside together. So we assume that these coefficients are 1, so that's just going to be 1 times 1, which is 1. And then multiply what's inside. 3 times 8 is going to be 24. Now, can this be simplified? The answer is yes. That is 4 times 6. Square root of 4 is 2. Okay. Number 8, again, multiplying radicals. My coefficients outside are just 1, so that leaves me just to focus on the inside. That's going to give me the square root of 50. That can be simplified. That is the square root of 25 times 2. Square root of 25 is 5. So lots of square roots of 2 on here. Number 9, 5 square root of 8. We can simplify the square root of 8 because 4 is a factor, and that's a perfect square. So we bring that 2 out. It's going to get multiplied on our 5, 10 square root of 2. Number 10, another multiplication. So we multiply with outside together. It's going to give us 6. Multiply with inside gives us 50. This, of course, can be simplified. So that's going to give us 6 times 5 square root of 2, which is 30 square root of 2. Multiplying radicals, 28 times 2 is going to give us 56. And can 56 be simplified? The answer is yes. This is equivalent to the square root of 4 times 14. 4, of course, is a perfect square, so 2 square root of 14. Now, 14, none of its factors are perfect squares, so we know that that is completely simplified. Square root of 7 times square root of 7, we kind of worked with that one on our last set. Multiply what's inside, that gives you 49. Square root of 49 is 7. Square root of 12, we can simplify that. It's going to give us 2 square root of 3. Square root of 60 is equal to 4 times 15, 4 being a perfect square. So 2 square root of 15. None of 15's factors are perfect squares, so we know that that has been completely simplified. Now 80. 80, one of 80's factors is 16, so 16 times 5 gives us 4 square root of 5. And then lastly, 3 square root of 75. This can be simplified. 25 times 3, bring out the 5. It's going to get multiplied by our 3 and give us 15 square root of 3. So hopefully by now you are more comfortable with this and can do more problems on your own.